Good day everyone and welcome to our next lesson. In this video, we'll be discussing solid wastes, what are their characteristics, and how do we manage solid wastes. So let's begin. Let's first define what solid wastes are. Solid wastes are what we commonly call as basura in Filipino. Solid wastes are the most visible environmental priority in the cities and municipalities in the Philippines, and it might surprise you, but solid wastes are also a big problem even in developed countries. That's because solid waste is a universal problem, and its mismanagement along with its growing volume is presenting a constant threat to all countries. Solid wastes are the wastes that are not transported by water and that has been rejected for further use. So solid wastes are commonly coming from the domestic side, that is your households, your commercial establishments, and your industries. We also call solid waste as refuse. And for municipal waste, we can also call that garbage or rubbish. What we normally call garbage are putrescible food wastes. Those are the food wastes that are biodegradable. And rubbish are the non-putrescible or non-biodegradable part of the solid waste. Those are your recyclables and non-recyclables. This is an example of a traditional open dump site that was the common method of disposing solid waste back in the early days of the rapid development of the Philippines after World War II. So what we see here is a big mountain of solid waste or garbage that has been exposed to the elements. So it is being exposed to the sun, exposed to the rain, exposed to the birds, and exposed to the people. A very good example of an open dump site is the Payatas dump site, which has already been converted throughout the past years to a controlled dump site, but it really started as an open dump site. There are several hazards presented by an open dump site, not only to the people living, but also to the environment, which we will discuss later. That is why we are no longer favoring the use of open dump sites. This is an example of an open burning performed in open dump sites. Open burning is being performed previously in dump sites because they want to keep the volume of the trash down or they want to make way for more garbage. This practice has already been banned due to the enactment of the Philippine Clean Air Act. So you must know that open dump burning is now prohibited in the Philippines. Since this is still an open dump site, it still presents hazards to the people and the environment. So this is not our preferred way of dealing with our solid wastes. What are the causes of solid waste problem? Generation of waste is increasing rapidly as consumption rises. This is also true as our population rises. Also, collection efficiencies are dropping as service levels deteriorate. This is true for large cities that are expanding. That is because for an incremental increase in the service area, the effort that needs to be placed into collecting garbage gets exponentially harder and harder. Treatment and disposal facilities are facing closure because of improper siting and management and growing public opposition. Of course, you do not want to be living beside a dump site or beside a landfill. That's why people do not want landfills to be near their areas of residences. That's why with our population rising, it's becoming difficult and difficult to secure the population's approval for the building of other dump sites or landfills. Another problem is urbanization and industrialization. With many people concentrating in large cities such as in Metro Manila, solid waste handling is a very big problem. Not only do we need to rely on our neighboring provinces to take care of our solid waste, we also need to invest more on infrastructure and facilities to take care of the growing population and the solid waste that is being generated by that growing population. Okay? Here are the common sources and types of solid waste. Let's start with the household level. In the household level, what you commonly see in the trash can are first food waste. That's very common. You can also see paper, different kinds of plastics, and other recyclables such as aluminum and tin cans and etc. For commercial and industrial wastes, the type of waste vary depending on the activity of the industry or of the commercial place. For example, if the solid waste is coming from an office, we would expect that the solid waste would be more of a paper-based or food waste-based solid waste. Okay? We also have farm and agricultural waste. Agricultural waste largely includes cellulosic materials such as rice straw, rice husk, coconut coir, and etc. Institutional waste, mining wastes, and hazardous waste. We will be allotting a separate discussion for hazardous waste. We also have some miscellaneous and specialized waste. This you do not see every day but are rather coming from specialized places such as specific industries. We can have residues of sewage treatment plants. We call this the treated sludge. Street sweepings debris caused by disasters. Large waste such as construction rubble. dead animals, and ash from incinerators and residues from the combustion of solid fuels. What are the factors that affect waste generation? First, the state of the national and individual economy. So, what we have found out is that the richer the country is, the greater is the rate of solid waste generation per capita per year. If you take a look at a more developed country such as USA, their lifestyle or their consumer lifestyle involves the use of packaged products because they can afford those packaged products. They are contributing more to our problem of solid waste. Okay? Demographic profile of the population, lifestyle of the people, and other factors. So now let's characterize the composition of solid wastes. We have here several factors influencing the composition of municipal solid waste. Remember that municipal solid wastes are the solid waste that are coming from individual households. Okay? The composition varies due to climate, frequency of collection, prevalence of home garbage grinders, which we don't have in the Philippines, social customs, per capita income, acceptability of packaged and convenience foods, and the degree of urbanization and industrialization of the area. In the Philippines, the last one is particularly true. If you take a look at the solid waste generated by urbanized areas, they are very different in composition with that of the rural areas. The rural areas generate mostly biodegradable and compostable components of their solid waste, while for highly urbanized areas, you can mostly see papers, plastics, and other metals in their solid waste. So what is the value in characterizing the composition of the solid waste? Well, it is important in several aspects such as determining if the solid waste should go straight to a landfill or if there is value to segregate the waste into its constituents, one for composting, one for recycling, and the other as residuals. We have here a table containing the common physical chemical characteristics of solid waste components. The most important parameter that we will take a look at here is the energy value of the components of the solid waste. We have here two entries for the energy value. You have the energy value as received and the energy value after drying. This is important if you're trying to extract energy coming from solid waste. We call that a waste to energy process. Incineration is an example of a waste to energy process wherein solid waste is being burned in a controlled manner in order for that to release heat, and the released heat can be used to boil water to form steam, and then the steam is used to produce electricity. If you take a look at the energy values after drying, you can see that plastics, as well as some textiles, rubber, leather, wood, and some papers all have high energy values. These energy values are what determines how much electricity can we recover from the waste. However, in the Philippines, incineration is not allowed for municipal solid waste. We are only allowed to incinerate hazardous waste that need incineration, such as biohazardous waste. Okay? Since we are not allowed to use incineration, we have to rely on other methods to contain our solid waste. Here are some of the characteristics of solid waste that might be used to classify them. First is density. The density is simply the mass of the solid waste with respect to volume. We have two types of density, the uncompacted density and the compacted density. The uncompacted density is usually the density of the solid waste at the collection point, meaning at your house. So that is mainly a high volume, low mass type of waste. Okay? That's why in some applications, it is important that we are compacting the waste such that the same mass of the waste would occupy a smaller volume, thus it would occupy a smaller volume in the landfill. Next is energy content. This is important for countries wherein they use incineration to recover electricity coming from their solid waste. Examples of such countries are Japan, Singapore, and some countries in Europe. Municipal solid waste contains about 50% volatile combustible matter with roughly equal proportions of moisture and inert solids. This information are important if you are planning to incinerate your waste. We have here a table detailing some of the density ranges for various types of municipal solid waste. If you take a look at the mixed municipal solid waste, the densities of loose solid waste ranges from 90 to 600 kilograms per cubic meter. That is for uncompacted solid waste. But after compacting and storing in a landfill, we can have densities as high as 1,100 kilograms per cubic meter. Again, it is important that we are compacting the municipal solid waste as much as possible in order for us to save space. Because again, the space in a landfill is limited and it's very difficult to open a new landfill because of the opposition from the population. So now that we have a background on what solid wastes are and what are the characteristics of solid waste, let's talk a bit about how do we manage and control our solid waste. First, let's lay down the reason why do we want to manage our solid waste. There is the obvious reason that unmanaged solid waste is very dangerous to the population and the environment. As such, that is our number one priority, protection of public health and the environment. Another reason is that solid wastes are usual vectors or carriers for disease transmission. You can have leptospirosis or dengue as two such diseases that can be exacerbated by problems with solid waste management in the community. Before the implementation of RA 8749, by the way, RA 8749 is the Clean Air Act of the Philippines, dump sites are the favored means of disposal. Dump sites are basically you find a vacant lot and then you throw all your garbage in that vacant lot. Preferably, the vacant lot is owned by the government or is rented from private owners. The dump is often burned to minimize the volume of the waste. This is what we saw earlier, wherein there is open burning in the dump site. That's because without burning, the volume of the garbage would be so large that the mountains of garbage would then collapse somehow. So that's why they were practicing open burning. But the implementation of RA 8749 has banned the open burning of solid waste because it has detrimental effects to our atmosphere. It is a causative agent for air pollution. And for obvious reasons, this is not an acceptable practice from both an environmental and health perspective. So building on that, since we no longer want dump sites to be our means of disposing our solid waste, let's talk about our waste management hierarchy that is being prescribed by RA 9003 or the Ecological Solid Waste Management Acts of the Philippines. You can see that this is an inverted pyramid, and an inverted pyramid tells us that we want to prioritize the steps at the very top such that the steps at the very bottom would be our last resort. Okay? If you take a look at the diagram, source reduction is at the very top, meaning as much as possible, we should be practicing source reduction before disposing our waste. So by order, we have source reduction, on-site recycling with segregation, off-site recycling, treatment, and finally disposal. Okay? This structure or this management hierarchy allows us to generate the least amount of solid waste possible. And we want to do that because, again, the spaces in landfills are limited and we do not want to run out of space as soon as possible. We want to stretch the life of the landfill as long as we can. And we can only do that with proper management such that disposal is our last resort. We will go through each of these steps individually. Let's start with source reduction. Source reduction, as the name implies, is simply the reduction in the amount of the waste stream. That means that you simply have to reduce your consumption of products that generate a lot of solid waste. Here are some requirements for the implementation of source reduction. We have adoption of industry standards for product manufacturing and packaging using less material. You are already seeing this in some of the products that are becoming more conscious of their footprint, no? You can see some of the food products that are reducing some of their plastic packaging, but that is of course without sacrificing the integrity of their products. Passing of laws that minimize the use of virgin materials in consumer products. This also encourages recycling of recyclable materials. Adoption of communities of rates for waste management services that penalize generators for increasing waste quantities. So these are all policy decisions that could help us achieve our goal of source reduction. Again, the goal of source reduction is to minimize the amount of waste that is being generated in the first place. Further examples of source reduction include converting heavy packaging materials to lightweight ones. This applies especially in the foil packaged materials such as packaged juice or sachets for shampoo, soaps, and other consumer products. Another example is making consumer products in concentrated form that require smaller containers or packaging. This is applicable for the fruit juice industry, in which they can market their products as concentrates rather than the ready-to-drink kind, which takes up a lot more waste. The next step is recycling. So we have two steps in the recycling. We have on-site recycling and off-site recycling. On-site recycling or segregation should be happening in your houses even before your solid waste gets collected. That means that you have to segregate your biodegradables from your non-biodegradables, and your biodegradables be segregated further into the recyclables and the residuals. Doing so would help us characterize which waste should go into the landfill and which waste should not. For example, food waste should never go into the landfill. Under the law, under Republic Act 9003, our food waste should be composted and turned into fertilizer. Okay? And what should be going into our landfills are just the residuals or those that cannot be recycled and are non-biodegradable as well. Examples of that are plastic packaging and plastic films, which normally cannot be recycled sustainably. Recycling requires the existence of a reliable nearby market for the recovered material. In the Philippines, this is the function of the junk shops, which are the repository for recyclable materials such as metals, plastics, papers, glass, etc. Market development will depend on the quality of the materials, overall industry capacity, and the cost of competing raw materials. Since recycling is being touted as one of our best bets in combating our solid waste problem, we need to talk about the benefits of recycling. The largest benefit of recycling, of course, is resource conservation. A very good example of that is the recycling of iron, aluminum cans, and waste paper all make a positive impact to the environment. That's because the recycling of metals are proven to reduce the amount of water and energy that is required from the mining to the processing and to the manufacturing. So the recycling of iron, aluminum, and copper are much more profitable than obtaining them from the raw materials. However, one of the biggest obstacles to recycling of metals is the acceptability of the recycled product. For example, iron can rust and that could hinder its recyclability. Aluminum in the form of aluminum foil or aluminum cans can be very cumbersome to recycle if they have biodegradable substances such as food waste that are adhering. Paper is also a very good substance to recycle because that saves on the virgin material. And as we all know, virgin materials for paper is wood, and wood right now is in very short supply because of unsustainable logging practices. Recycling can also prevent pollution because again, instead of us mining more to get more ores and processing, we can just remelt our scrap metals to form our products. And that entails less pollution from mining and processing. I have also mentioned this earlier, energy conservation, because it takes less energy to recycle metals than to mine them and process them again. From our solid waste management paradigm, after source reduction, after recycling, we have the treatment stage. The treatment stage takes into consideration everything that can be done to the solid waste before it is sent to its final destination, which is the landfill. Let's start with solid waste handling or processing. Handling refers to all activities associated with the handling of solid waste until they are placed in their storage containers. The transfer of loaded storage containers to collection points is also a part of the handling process. So the moment that you throw your solid waste into your trash can, and then the municipal garbage truck collects your trash, and then that trash is transported to a collection facility, those are all steps of the handling processing stage. We have here the elements of a solid waste management system, which includes the generation of the waste coming from the households, storage of the waste still in the household level. Now, this is the stage wherein segregation must already happen, okay? So there is segregation in the household level, and there is also a second segregation in the transfer stations for all of the waste collected in the vicinity. After storage, there is collection. So this is where house-to-house collection is crucial. And then from collection, you have transfer and transport, processing and recovery, and disposal. Processing and recovery is the off-site recycling option, okay? Collection systems are characterized by their ease and frequency of pickup, the type of collection equipment. Of course, that would vary depending on the serviced area. Normally, they are all trucks, but the size of the trucks would vary again on the size of the collection area and the rate of generation of the households. This is an example of a compactor. The main purpose of a compactor is to increase the density of the municipal solid waste such that it would occupy a less volume in the landfill. Another purpose of the compactor is to turn the shape of the municipal solid waste into a rectangular polyhedron. In that way, they can be stacked together without any space in between of the shapes. Okay? So it's all about efficiency of packing in the landfill. For the separation and processing of municipal solid waste, again, we are still on the treatment stage. We are building upon on the results of the recycling stage. On the recycling stage, we are able to separate the recyclables from the non-recyclables, the biodegradables from the non-biodegradables. Everything that is biodegradable must be handed over to composters. It could be a localized composter in which every house has a composting bin, or a municipal composter wherein the composter is part of the materials recovery facility. By the way, we have structures that we call MRFs or materials recovery facilities. These facilities are required to be in every barangay of the Philippines or every cluster of barangays in the Philippines. This is mandated by RA 9003. The main function of an MRF is to perform off-site segregation and recycling. Ideally, all of the solid waste that is being generated by an area first goes through an MRF for sorting, recycling, and composting before the residuals are sent into the landfill. Okay? This is another treatment process, however, it is not allowed in the Philippines. That is conversion of solid waste by incineration. Incineration, again, is the process of continuous burning of the solid waste. Incineration serves two purposes. The first one is to reduce the amount of solid waste up to 90% by volume and 75% by weight. That's because the residue of incineration is ash, and ash is easier to dispose and is less bulky than the fresh solid waste. The second purpose of incineration is to recover energy from the solid waste. If the residual solid waste is of a high energy content, such as if it contains a large portion of plastics and paper, we can use it to generate electricity. However, I would like to remind you again that incineration is not allowed in the Philippines by the virtue of the Clean Air Act. One of the reasons why incineration is not allowed in our country is because of its health and environmental risk. The primary risks for humans is air quality problems. Examples are dioxins and furans, which are being generated every time you burn plastics. Every time you are burning plastics and rubber, you are sure to be breathing in dioxins and furans, which are very toxic in our body. Another problem or risk in incineration is the concentration of heavy metals in the ash or the residue of the incineration. Okay? That is considered as a hazardous waste. One of the most favored treatment process in solid waste handling or management is composting. Composting is applicable for any organic biodegradable waste. In particular, we are pertaining to aerobic composting, wherein a compost bin is constantly being mixed and turned in order to incorporate oxygen into the matrix of the compostable solid waste. We are doing this because aerobic decomposition is safer for the average household, and it also does not release toxic gases such as methane and nitrous oxides. In aerobic decomposition, one of the indicators that decomposition is happening is the increase in the temperature of the pile. Composting is controlled, accelerated biodegradation of organic matter into humus. And the product of composting is compost, which is a very good soil amendment or fertilizer. For optimal conditions, 55% moisture content and regular aeration are required. Regular aeration is achieved by the constant mixing of the compost pile. If anaerobic conditions are allowed, such as if you forgot to mix the pile, if there is no oxygen, then objectionable odors will be released, as well as some pathogenic bacteria could also proliferate in your compost pile. That's why we generally want to achieve aerobic conditions. Other treatment process that can be used depending on the type of waste, we have wet oxidation and pyrolysis. Pyrolysis and wet oxidation are normally used in treating plastics, especially pyrolysis. If we want to recover fuel from plastics, we can use pyrolysis. Pyrolysis is simply the heating of a material until it undergoes thermal decomposition in the absence of oxygen. That means that we are not burning the material, we are just heating it until it decomposes. Now we are on the final step of the solid waste management paradigm, which is final disposal. Disposal in our case can only be carried on landfills or modern sanitary landfills. By the passing of RA 9003 or the Ecological Solid Waste Management Act of the Philippines, the opening of open dumps are no longer allowed, and all of the existing open dump sites must be converted into controlled dump sites. Controlled dump sites are the middle ground between open dump sites and modern sanitary landfills. So let's discuss what makes a well-engineered modern sanitary landfill and how can it make us safe from our solid waste. What is a landfill? A landfill is a clay-lined depression in which each day's deposit of fresh garbage is covered with a layer of soil. Selection is based on groundwater geology, soil type, and sensitivity to local citizens' concerns. Landfills have bottom layers to trap contaminant-laden water or leachate leaking through the buried trash, and leachate is collected and treated. These are all the characteristics of a proper sanitary landfill. So what does a landfill look like? This is a cross-section of a landfill. So you see here that this is the soil. Normally, we want to build a landfill if the soil is clay because the layer of clay protects our groundwater resources. The liner is laid out in the bottom and in the walls of the landfill, and the liner could be natural, that is clay, and it could also be artificial, such as HDPE or high-density polyethylene. The function of the liner is to restrict the seepage or the diffusion of leachate, which is very polluting and detrimental if released to our groundwater. Above the liner, we have the leachate collection system, which is normally consisting of a pump and a pipe that is buried in a layer of gravel. The layer of gravel protects the liner from being punctured by the garbage. We also have a gas recovery system for the methane because methane is always being produced in a landfill. The methane either needs to be collected or flared in order for us to either make use of it or nullify its polluting characteristics. So after the layer of the liner and after the layer of gravel, we then have your refuse or your residual solid waste. The residual solid waste after each day should be covered by a layer of soil that prevents animals or other scavengers from scattering the trash. We call this a cell. A cell is a single unit in a landfill, and a landfill can have multiple cells. So in the operation of a landfill, what normally happens is you first need to fill a cell before topping it off with a cap that is normally made up of soil and grass before you move on to filling another cell. In a landfill, we also have a leachate treatment system. The leachate treatment system is where the leachate coming from the bottom of the cell of a landfill goes for it to be treated. The treatment of the leachate is generally the same as the treatment of wastewater. So if you go back to our discussion on wastewater, all of the steps there are also employed in the treatment of leachate. Leachate is normally characterized as having a very high value of BOD and COD. That's why aeration is a very important part of the leachate treatment system. The leachate can also undergo anaerobic processing if our goal is to produce more methane. By the way, the leachate that is being collected from the leachate treatment system and the gas recovery system can be used as a source of electricity. Methane is a very good fuel. We can combust it in order to heat water, produce steam, and then generate electricity. However, for smaller landfills, this might not be sustainable. There are some cases wherein it's not viable to build an entire methane power plant beside of a landfill just to make use of the methane. So for those types of situations, we still do not want to release methane into the atmosphere. So what we do is we have flaring. Flaring is a process wherein we intentionally combust the methane that is being generated in the process. We do not want methane to be released in the atmosphere because methane is a very potent greenhouse gas. If you go back to our previous discussion on air pollution control, methane has a global warming potential of 21 to 24. That means it is at least 21 times more potent than carbon dioxide. Okay? So by flaring, we are at least converting the excess methane to carbon dioxide, which is less potent than methane. Here are the following design criteria that we might want to apply in our landfill. First, it must be an inexpensive land within economical hauling distance, have year-round access and at least 1,500 meters downwind from residential and commercial neighbors. This is the reason why in the future it will be harder and harder for us to build new sanitary landfills as our existing sanitary landfills are being filled. That's because nobody wants to live near a sanitary landfill. And as our population rapidly increases, there will be less and less non-objectionable areas for building of landfills. Area should be clear, level, and well-drained. It should have a capacity for not less than 3 years of use. For designing sanitary landfills, we normally want to build landfills with service capacity of 20 years or more. Okay? The site of the landfill should also have a soil of low permeability. That's why we normally use clay. And it should be well above the groundwater table. The last thing that we want when building a landfill is polluting the groundwater. Here are some of the problems that we normally encounter for sanitary landfills. The biggest problem, especially if you ask the people, is the aesthetic considerations, the beauty factor. Of course, as I've mentioned earlier, nobody wants to live beside a landfill. First, because it's very unsightly, it's not beautiful to see, and of course, we have the unwanted odors. Even in the most advanced landfills wherein they use chemical agents to suppress odors, there is no landfill that does not emit any odor. Okay? So odor and aesthetic considerations are the people's biggest problems regarding landfills. Another problem is economic loss because you are using a land that could be economically profitable to store solid waste instead. So in some cases, this can be addressed. There are cases wherein a sanitary landfill, after reaching its end of life, meaning it has already been filled and capped, can be converted into attractions such as golf courses and parks. I will show you an example later. Lastly, we have environmental effects which are unavoidable whenever we are solving a problem related to the environment itself. Some of the environmental problems include the leachate, which is high in organics. That's why I've mentioned that the leachate is very high in BOD and COD. It can also be high in some toxic components. Another environmental problem coming from landfills is the methane if you are not collecting it. That's why open dump sites are very problematic because the methane cannot be collected and it's just continuously being released to the atmosphere. Also, heavy metals contained in the leachate can be a big problem for landfills. Here are some example pictures for the preparation of landfills. For the digging of the cells, the exact dimensions of the cells are dependent on how much solid waste is designed to be placed into that cell. I have here two images that show you that the land used for landfilling is not always useless. These are parks that are developed on top of a spent landfill, meaning that the landfill has already reached its full capacity. All of the solid waste have already been capped with soil, and then the site has been developed to become a park and a tourist attraction. So we can still recover some economic benefit from the land used for landfilling. However, this process takes many years, and you are very limited on what structures you can build here. Because remember that you cannot build tall structures because you only have a thin layer of ground, and then beneath that is many layers of garbage. However, this shows you that we can still rehabilitate the sites wherein there was previously a landfill. Okay, that's it for this lesson. I hope you have learned something about the handling of solid waste. Please watch out for our next lesson, which is the handling of hazardous waste. Thank you for listening, and as always, keep safe.